Hello everybody, I am Dr. Farhan Zameer from Biotechnica, Bangalore. Today we are here for a very intense series on my research topic, and especially this would be on transforming ideas to innovation. So for today, we are trying to dwell upon a very interesting topic on biodiversity, and this topic has been captioned as medicinal mushrooms. So what exactly is this? How exactly one can pursue research on biodiversity, especially on mushrooms? Let us try to understand in detail. Let's dwell in. Welcome back. As I have promised you, so we are here for a very intense my research series which talks about how do I translate, how do I transform ideas to innovation. Now here there is a small glimpse of a work which was being done by one of my students whom I actually mentored, a student from Iran. So this student was able to do a lot of work on medicinal mushrooms, and how exactly was the data accumulated and compiled. Let us try to look into it. So coming on to mushrooms, this student has worked on a very special kind of a mushroom, and this mushroom, which is nothing but the fungus. So this is on to the diversity, nutritional value and isolation of bioactive principles from a very special kind of a mushroom, that is a fungus, which is called as Termitomycetes species, which was being isolated from the Kodagu districts in Karnataka, India. Now, before I actually move upon, I need to actually explain you what exactly are these special variety of mushrooms. These are called as the mushrooms which grows with symbiosis with that of termites. So these are actually inside the termite hill, and once you have the termite hill which are being produced, so inside this fertile area, this is a beautiful pure culture of the fungus which grows, and this is called as Termitomycetes. Now so there is a close association of the termite and the fungus. So what we need to understand is the soil over there, the termite hill, has certain nutrients, and these nutrients are not directly being utilized by the fungus itself, and hence these termites has to actually ingest that particular the micro and macronutrients, and once they ingest this micro and macronutrients and they excrete it. Okay, so upon excretion, the excreta is actually the feeder, or it is the nourishment or the nutrient for the fungal species to actually develop, and the species developed as a pure culture fungus, and this species is within the association of the termite, and hence it is called as Termitomycetes. And you can see in this particular panel that the pure culture develops inside the termite hill, and then it will try to protrude out onto the surface of the soil. So you might be surprised to know that this is a fungus which forms inside below the ground, that is inside the termite hill. And if you look upon this particular panel, so this panel explains that this termite hill is not a small termite hill. So this is a student from Iran. His name is Dr. AB. So Abul Fazil, actually he worked on this Termitomycetes, and he was of an height of around 6.2 or 6.3, and you can see that in the picture how exactly the termite hill is of around around 6 feet height. So under this there is the beautiful consortium of these microorganisms, that is this fungus in association of the termite, and this combination is called as a special kind of a mushroom which has a huge potential for medicinal value, and hence this particular topic is of a great relevance. Either these mushrooms could be again, as I told you, these are like edible mushrooms, so these mushrooms could be directly eaten up, or these mushrooms could be utilized for isolation of certain pure molecules, and from these phytomolecules or from these metabolites you can have certain medicinal value which are called as fungal medicines. Now, moving on forward, so with his research work, he was able to come up with various varieties of, Termitomycetes mushrooms, and very importantly, he was able to identify more than, 8 to 9 varieties of, Termitomycetes species, which starts from, Termitomycetes micro mummiformis, micro termitomycetes microcarpus, then Termitomycetes indicus, Termitomycetes hemi. All these are various kinds of Termitomycetes which are being edible. Few are edible and few are non-edible. But the very important component is you can look into such a huge biodiversity of mushrooms, okay, especially in the medicinal mushrooms under the ant hill or under the termite hill, okay, and this grows in association with the termite. So the termite actually gets its food, and even the processing of that particular food later acts as a substratum for the fungus to grow. Now, there is an interrelationship with the ecosystem. So, humans, people they harvest, the local people they harvest, and then, that's a source of revenue generation. They are also able to maintain the biogeo, cycles in the soil. And then, since it is in association with the insects, so there are a lot of insects which grows over there, which will actually enrich the soil fertility. So there is a beautiful interconnection between the Termitomycetes and that of the fungus. So there's a beautiful interaction between the fungus and the Termitomycetes. So where do we come into picture? Now here, when we are trying to understand the entire components of various species of fungus or Termitomycetes species, then we were able to do DNA sequencing for all the species, and then we were able to draw a blast result, wherein bioinformatics plays a very, very important role. So in the wet lab or in the dry lab, you can amalgamate data and you can strengthen your data using bioinformatics. And that is where at Biotechnica, we feel that all internships, all certification programs are very, very important, so that where the additional amount of knowledge you gain, your research gets empowered. So with Termitomycetes data, the candidate was able to know that whether these are known species of Termitomycetes or unknown species of Termitomycetes, and that is how phylogenetic analysis was being done. Now, upon phylogenetic analysis, trust me, my dear friends, all these mushrooms, that is Termitomycetes, they grow in a specific niche, that is with a specific habit and a habitat they are able to grow, and there was no standardized protocol to grow them in an experimental system, that is in a laboratory system to grow them. So this candidate was able to develop methodologies wherein you can grow these Termitomycetes not just inside the termite hill, but however it was also grown in the laboratory. Now, what is the advantage of this? This is an evidence that once you grow into the laboratory, you can actually scale it up. Because directly isolating mushrooms from the termite hill can lead into disruption in the biodiversity, and hence there should be an alternative method to culture them. So these are the various alternative methods wherein they were able to develop the mushroom inside the laboratory onto a Petri plate, and that is how you can isolate various kinds of metabolites which have been released. So these metabolites are of highly demand because of their medicinal value. Now, how do you know that these are of high medicinal value? So what Dr. Abul Fazil he did was he took up that particular culture from the starter culture, was from the natural habitat. Once there was a starter culture which was been taken up, and that was actually cultured in the laboratory under in vitro conditions. And once there was a development of the metabolite was being harvested. Okay, using various solvent gradation method, the metabolite was been harvested, and these metabolites were again further tested for their bioactivity. Now, when they tested for bioactivity, especially cell line model was being used, and colon cancer cell line was being used here, and the raw cell line and the colon cancer cell line, that the HT29 cells were used to know whether there is cytotoxic effect of these particular molecules which have been isolated from Termitomycetes. And for our surprise, there were two new proteins which were being isolated and were identified from these cultures. Okay, so the two important molecules were, one was E3 ubiquitin protein like ligases, and the other one was extracellular mutant protein, that is ECM11. These two very important proteins were isolated. Now, we normally use various kinds of softwares to understand this, and for this kind of a data, especially mascot software was used to understand what exactly is the phytomolecule which is responsible. And when you look into the various kinds of DNA studies, so we now know that there is absolutely destruction of the colon cancer cell. So that is how your termitomycetes metabolites could be utilized on cancer disease or a disorder. So with this, I just wanted to let you know that it depends on your thinking ability. That depends on how exactly you can connect things. Okay, you started with biodiversity, looked upon the culturing methods, then isolated phytomolecules, and from there you are able to elucidate new proteins which had a larger biological role as fungal medicine. So this is how at Biotechnica we are able to mentor you at any level at in your research. Many a times our students, they complain that sir, I am a research enthusiast, but I don't get a right guidance at a right point of time. So this is how we actually help you out to understand whether your research is feasible and within a given framework. So if not, we are trying to put up a roadmap for you so that you can do your research in a much better way. So for any queries, please do write to us at support@biotechnica.org, and we are there for your assistance 24/7. We will make sure that you you create good research, you create good data and publish well. So for any kind of assistance, we are always there. We work with a rapid phase, we are reliable, and many a times the framework what we have designed is so reproducible, so that you can publish it in a very, very good journal. From point A to point Z, we are there for your support, and this is what we are trying to do it at Biotechnica, so that we can empower you at your research. Until then, take care. Goodbye.